programme, we're going to discuss the lovely ringed planet Saturn. And at this moment, in my observatory, my telescopes are being made ready in the hope of a clear sky. But first of all, our usual news notes with Chris Lintott. And of course Mars very much in the news now with the arrival of a new American probe.
That's right, this is Mars Reconnaissance Orbiter, which will spend the next several years studying the atmosphere, the weather and the surface of the planet. It's due to enter orbit on March the 10th, so let's hope everything goes well.
Meanwhile, down on the surface of Mars, those two amazing rovers, Spirit and Opportunity, are still going strong.
That's right, they're just about to enter their second Martian winter, which is a difficult time. They don't get as much power as normal, so scientists are really trying to get as much as possible from them now. Spirit is at an area called home plate.
What is it?
Well, it looks like a baseball diamond, apparently. It was visible from orbit, and it's not clear what it is. It could be a volcanic feature, some strange impact. Spirit's finally reached this point, and it's discovered this outcrop. And you can see many different layers of rock. So the plan now is to go up close, study that, and really work out the history of this strange feature.
Plenty of evidence now of past water there.
That's right, from both the rover sites.
Yes,
so it's clear that water was abundant on Mars. And it's not just the rovers. We've got amazing results from Mars Express as well.
These pictures are quite incredible. Phlegethon, for example.
That's right. This is an area just south of a large volcano which pops up at several kilometres above the plain. And what happens as that upheaval occurs is that material such as this is cracked and regions drop down, and you can see that quite clearly in this image.
So I think my favourite picture so far is Juvente. Juvente Chasma.
This is wonderful. This is a sulphur mountain, first seen in the images and then confirmed with a spectrograph on board the spacecraft.
Chris, thank you very much.
A pleasure.
And now on to our main programme, the lovely ringed world of Saturn. It's a giant, more than 70,000 miles across. And it goes around the sun at a distance of nearly 900 million miles. Even so, it looks bright, brighter than any star. Not solid, of course. It's made up mainly of gas and liquid, and the actual density is less than that of water. It's said if you could throw Saturn into a vast ocean, it would actually float. Of course, the main glory of Saturn is its ring system, made up of small, icy particles spinning around the planet in the manner of miniature moons. And Saturn has a whole satellite family of its own, and some of the satellites are big enough to be seen with small telescopes. Well, those are a few facts about Saturn. And now, out to my observatory. Chris, can you see anything?
Well, Patrick, sadly, it's completely cloudy. But Pete, you've got some images of Saturn taken just a few weeks ago.
That's right. I've been watching Saturn this time round, and I decided to try using a video camera, a special video camera optimised for astronomy. And that's quite a good representation of Saturn as you would see as an amateur looking through a telescope.
Oh, it's a beautiful object, isn't it?
It is. When you look at Saturn through a telescope, that's the hook for a lot of people to bring them into astronomy.
Well, it was for me, certainly.
It was for me as well, actually. But it is a superb object to look at.
And the first thing you notice are the rings.
That's right. The rings are very striking around Saturn. You can see the shadow of the planet on the rings, and you can see the gaps in the rings, or one particular gap, which is the Cassini division.
Now, what are the rings made of?
Well, we know they're made of ice, at least predominantly ice. We can tell that from their spectra. And they are typically sizes of about a few centimetres across, bigger in some places, smaller in others. There's actually a whole spectrum of sizes.
And the rings are actually very, very small indeed.
We really still don't know the dimension. It may be perhaps as thick as the largest ring particles, so perhaps a kilometre or so. But there really is no way of knowing so far exactly how thin they are. But the extent is just enormous system. 130,000 kilometres out to the edge of the A ring gives you some idea just how thin these rings are.
Well, these are images of the F ring just outside the main ring. And what on earth is going on here?
Well, that's what we're trying to understand. We know that Prometheus and Pandora, the shepherding satellites on either side, have a gravitational effect on the F ring. We know that this moon Prometheus, one of the two F ring shepherd moons, actually directly interacts with the F ring, goes in every orbit, pulls out material just by pure gravitational attraction. That material then goes back into the ring. There's a channel created, and those channels shear. And we can actually see these in the images. As we look around the ring, we can see the effect of Prometheus. But we also believe, based on our images, that there are small moons orbiting within the F-ring. Now, we think these moons are, well, we actually don't even know if they're moons. They may well be just clumps, temporary clumps of material. You can see one moon here, one object which appears on the outside, and we believe that's the same object that later on appears on the inside. So this is it's not really a shepherding moon. It's sort of, the sheepdog's gone a bit wild here. It's sort of crossing through the ring. The general conclusion we're coming to is that we're really looking at a young ring, maybe even formed at the same time as Prometheus and Pandora, and we're just looking at the remnants, because over the age of the solar system, this should all have sorted itself out. The rings would have collided with the moons, the rings would just settle down, maybe the ring would have disappeared altogether, and yet we're seeing a very dynamic, very unusual ring system, and one that's posing a lot of problems for us.
And you can see what has been suspected for a long time, that each of the gaps in the ring seems to be associated with a moon.
That's right. We knew that the Encke gap, which is in Saturn's A ring, was associated with a moon pan. We had suspicion that because of wavy edges on the Keeler gap that we just about detected with Voyager, that there was also a moon there. Sure enough, that moon has now been detected. That's now called Daphnis. But there are other gaps in the rings. And again, our best theory is that these are caused by small moons that we have yet to detect.
There's surprises wherever you look, like the aurora on Saturn. Who would have thought we could see that?
Exactly, and we see, the parallels with Earth are right there. We know we have the aurora at the north and south polar regions. We can see that again with Cassini. We've seen storms, beautiful system. There's what we call the dragon storm.
It's an incredible image.
It is. We've seen this storm evolve and disintegrate before our eyes. We've also, of course, detected the storm that was first seen by the amateurs in January. We, because of the long orbit that we were on, were looking at a sort of crescent of Saturn, whereas the amateurs, the view from Earth, gives us almost a complete disk. Now, we did do something with Cassini on the dark side, using actually the ring shine, sort of reflected sunlight, to image what we think is the storm system. We've recognized that in about 35, 36 degrees southern latitude, we call it Storm Alley. We see these storms develop and evolve and die, and be really interesting to know what the source of this is and how it's again related to the orbit of the planet around the sun.
Well, I can't wait to see the next 2 years' worth of results from Cassini. Meanwhile, the amateurs will do what they've always done. Keep an eye on the planet night after night and look out for developing storms. To find out more, Patrick's outside.
We've seen those superb pictures, and I'm glad to say I'm now joined on my observatory by 3 of our best amateur Saturn observers, Damian Peach, Dave Tyler, and Ian Sharp, and they're doing splendid things on Saturn. First of all, Damian, may I come to you? I remember the white spot on Saturn in 1933, discovered by Will Hay. Well, do you know a white spot now?
There is a white spot now. Here we can see 4 images of the great white spot that erupted on Saturn in 1990, which is the same kind of spot that occurred in 1933.
I remember that one very well.
That was a massive eruption of clouds on Saturn. There have also been other storms to occur on Saturn, and we see here some images from 1994. A white spot has erupted in the equatorial zone of Saturn. These kind of storms periodically occur on the planet over the course of several years, but these large eruptions typically only occur every 30 years. There was also another large storm on Saturn in 1996, but neither of these later storms were to the degree of the massive 1990 storm. Moving on sometime later, we have 3 images presenting colour changes across the globe of Saturn between the course of 2004 and 2005. Here we can see that the colours gradually change across the course of time. This is due to chemical changes in the upper atmosphere.
Well, Dave, you've been following these, haven't you?
Yes, we have, and we've got some nice pictures of them. On the very first image here was taken by simply holding this up to the eyepiece of a 6-inch refracting telescope. And then I stopped using this and I put a webcam in there, and immediately the pictures improved dramatically, but the colour is still not quite right. Now I changed from the 6-inch refractor to this 8-inch reflector, and immediately the colours were just right.
Ian, what's the latest news? You've been observing Saturn also.
Yes, indeed, and this image is an image of the latest storm that is actually around on Saturn now, and we were hoping to get an image of it this evening. This was taken on the 10th of February, just a few days ago, and it shows the storm quite well. It has sort of started to smear out slightly as it's getting older, so it is changing over time.
I wonder how long it will last.
Well, that's an interesting question. They vary, but this one has been around for a good couple of weeks already, and hopefully another couple of weeks or a bit longer.
You know, pictures like this are lovely to look at and also very valuable because this picture, far better than anything that could have been taken with any telescope when I began the Sky at Night programme.
Absolutely, yes. It is incredible that technology allows us amateurs to actually get better images now than I could ever have seen when I was a boy, for example, looking through the best images that were published.
Well, they are splendid pictures. And in my view, you know, Saturn is the loveliest thing in the sky, with the disk, those marvellous rings, and of course the family of satellites. It's a large family. Iapetus, the outermost of the fairly big icy satellites, more than 2 million miles from Saturn, and then further out still, about 8 million miles, Phoebe, a strange world going around Saturn the wrong way and almost certainly coming in from the outer solar system. And beyond Phoebe, more newly discovered very small satellites, almost certainly ex-asteroids. So that makes a very varied family. Well, I've come back out of the cold into the warmth of my study, and so has Professor Carl Murray. And we're joined now by one of our most regular and welcome visitors, Professor John Zarnecki.
Hello, Patrick.
Well, we must begin with Titan, bigger than our moon with a dense atmosphere, a weird world. What's the latest news?
We're now at a stage where we understand some of the basics. For example, we understand, at least at the part of Titan where Huygens descended, the structure of the atmosphere, you know, the temperature, the pressure profile, how the density varies.
What is the main atmosphere? Nitrogen?
It's nitrogen, yes, with, of course, methane, hydrogen, and then this whole array of hydrocarbons, these increasingly complex molecules, which, of course, is one of the main reasons why Titan is so interesting.
Any liquid there?
Now, that's the tantalizing question. We don't see any standing liquid from the Huygens data. However, I'm absolutely convinced that it was damp where we landed. You know, I think there's very strong evidence that the icy sand that we landed in was damp. So there was liquid there. Was it a week ago? Was it a year ago? Was it 100 years ago? We don't know.
Does it rain on Titan?
Yes, clearly it does. I mean, we have these wonderful images of these drainage channels, and some of the latest results, which we can see here, actually show a 3D reconstruction of this system of dried up rivers. It's about 5 kilometers to the north of where we landed, and we can see these gullies and channels, rather steep walled ones, which I think means that when it did rain, the rain was pretty violent and they produced these steep gullies.
Titan has a deep, dense atmosphere, and it's windy there too.
It is indeed, and we're beginning to understand the structure of the wind. In fact, we've got a sound file here, which I think we can play. Now, this represents the signal that Cassini received from the Huygens craft, and it's been converted to sound, and you can hear now Huygens is beginning to slow down as it decelerates at the top of the atmosphere from 20,000 miles an hour down to a much lower speed. There it is, it's changing. And now it's under the parachute and it's now subject to the wind. It's being blown about by the wind. And by analysing the subtleties of this signal, we can work out the wind speed, the wind direction. There it is hitting the surface and the signal changes completely.
Is there any activity going on there now?
One effect that's some tantalising evidence for is some sort of low temperature volcanism. There is some evidence that material is seeping up through cracks, through ridges, maybe even through something that we might call a volcano, but of course a low temperature effect. Yes. And this might be material, volatile material, methane, perhaps being extruded up from below the surface. But, the jury's out at the moment.
Then, much further in, we come to this strange moon Enceladus, with its fountains, totally unexpected.
Well, absolutely right, Patrick. We saw these plumes coming out of the south pole of Enceladus. And the story of how we managed to accomplish this goes actually back to early last year. And the magnetometer experiment on Cassini, which was led by Michel Doherty, our Cassini colleague at Imperial College, detected some sort of conducting medium. And after 2 flybys, they deduced that this was actually material actively coming out of the south pole of Enceladus. Enceladus has these tiger stripes, which are ridges which are somehow producing material, actual active volcanism, geysers of material coming out. And we finally confirmed this with the imaging in November last year, when we could actually see these plumes, a sort of crescent Enceladus, and the plumes extending over several hundred kilometers from the surface. So Enceladus, I mean, this is the bizarre thing. There are bigger moons, there are smaller moons. Why is this one geologically active?
I've noticed this weird world with a mountain ridge more than halfway around its equator.
What we knew about Iapetus was that it's this black and white moon. The leading hemisphere, the one that is going round Saturn, appears to be dark and has a covering. Some of our images that we got early last year, we can see what looks like streaks going in a sort of north-south direction at the boundary of this dark region. And it's suggestive that this is actually a covering. Is the ridge somehow connected with the material? Because maybe the material isn't being accreted as it goes round Saturn. Maybe the material is coming from sort of some early volcanism early in the history.
The
of the
height
Iapetus.
of the ridge is just enormous, isn't it?
Yes.
Higher than Everest, isn't it?
Yes, it dwarfs
How
anything.
on earth do you explain that?
I think it doesn't seem to be active now, but maybe this is something that happened early on. I mean, are we looking at two different phenomena that are completely unconnected, or is there some connection between them? We don't know.
Well, rather close to it, a much smaller satellite, Hyperion. This really is an oddity.
The puzzle was how an object that was as large as Hyperion could still have an irregular shape, because we thought the self-gravity would be sufficient to pull it into a near spherical shape. For example, objects like Mimas have that sort of near spherical shape, and are icy objects. The key is now we've got a measurement of the density, and it turns out to be about 0.6 grams per cubic centimetre, and the ice is 1. Therefore, even though it's an icy object, it appears to be underdense. But we see this object that looks like a sort of giant sponge. There are dark regions we can see on the surface, and perhaps they've absorbed more sunlight than the bright regions.
And it's tumbling along in this orbit too.
Exactly. We knew after Voyager, and people made measurements of the shape, that it's actually rotating chaotically. And that's consistent with the Voyager observations and ground-based observations. So it's not just rotating chaotically, it's tumbling over its axes on a timescale of just a few orbital periods. And we seem to have confirmed that with Cassini.
I just wonder. Well, both thank you very much indeed. Don't forget, Saturn is still visible in the evening sky. It's in Cancer, near the lovely cluster M44, the Praesepe cluster, and this photograph by Pete Lawrence shows it very well, so do go out and look at it. Also remember, Saturn's rings are still well placed, but every year from now, for the next few years, they'll close up, and for a time, Saturn will lose its beauty, so make the most of it while it's there. This program, something quite different. There's going to be a total eclipse of the sun on March 29. Not from here, I'm afraid. There'll be a small partial eclipse from here. To see totality, you've got to go abroad to places like Turkey, and that's where Chris will be with our Sky at Night team. But from here, you can see a partial eclipse from about 10:45 to 12:20, and nearly 1/3 of the sun will be covered. But again, as I said before, please remember, the sun is dangerous. Observe it by all means, but take the greatest care. So, meanwhile, let's hope we have clear skies here, and good luck to Chris and the Sky at Night team over in Turkey. So until then, good night.
Wonderful. The sun also makes a fascinating subject for an evening of programmes which include a special edition of The Sky at Night. Bit of a contradiction in terms, that. It's tomorrow from 7 over on BBC 4.